Dear student, now the new topic we are going to discuss, that topic is vectors. What do you mean by vector? You know, vector is a direct line segment, that everyone knows. You know the concept, how to add, how to subtract, all those things you know. But now, so far you never heard about the word product. Product means what? When we multiply 2 and 3, you may say 6. The answer may be absolutely correct. But we say in vectors, I cannot say like this. 2 and 3 is 6, whereas A and B, I cannot say as either dot or cross. So, we are going to use two different notation for product of two vectors. Product of vectors, we are going to use two different notions. What are they? One is dot, the other one is cross. These are the two notation that we are going to use for product of two vectors. Product of two vectors, we are not using as we do so in usual mathematics as 2 and 3 is 6, but here we cannot do so, we cannot say so. Or in what way we can take it? It is A and B, this is nothing but dot and this is nothing but cross or vector product. So, now I am going to interpret two different notations for your information. That means, let us discuss only about dot, that is scalar product of two vectors. Now, I am going to define only about dot product of two vectors, in other words scalar product of two vectors. First, let us define about the vectors now. What is the definition of scalar product of two vectors? Definition or define, let A and B be two vectors. Two vectors we are defining, and those two vectors let me represent. First of all, it will be like this. One is A vector O and this is A, here A vector. The other one is like this. This is B vector, point is B. I am representing O to A is A, O to B is this, the angle is theta, remember that, angle is theta. So, now we have taken xy plane and this is y here, remember that, this is y, this is x dash, like this. Now, this is A vector, this is B vector, angle between them is theta, it is not a given angle and all, simply theta. The definition of this, A vector dot B vector is equal to mod A mod B cos theta. Remember that the definition of A vector dot B vector is mod A mod B cos theta. What about theta? Lies between 0 to pi, where theta value lies between 0 to pi, the first and second quadrant, it keeps like this. So, first and second quadrant, theta value between 0 to pi. This is the definition given by any book or anything, this is the definition. Okay. With that it is over. No, properties, we are discuss the properties, list of properties we are going to see, list of properties. What are the list of properties? First part, commutative property, commutative law. That means what is that? A vector dot B vector is nothing but AB cos theta. B vector dot A vector is BA cos of minus theta, remember that it is clockwise direction, it is this one. A dot B is AB cos theta and B dot A also AB cos theta, because cos of minus theta is plus cos theta, because cos is an even function. So even though the angle has changed, it is towards direction like this. A dot B is like this. This is A, this is B for A dot B, and B dot A is like this. The angle is minus theta. Though the angle has changed, it is even function, the same answer. So commutative properties holds good. A dot B is equal to B dot A. Remember that. That is a formula for the first one. A dot B is equal to B dot A, the first property. So how A dot B is AB cos theta as such the formula, and B dot A is, though it is B minus cos theta, but it is cos of minus theta is plus cos theta, both values carries out same answer. So A dot B is equal to B dot A, that answer is same. Okay. Second property, property number 2. Here A vector dot B vector equal to AB. Let me write like this. What does it mean here? That means, first part here, before going to see this, let me put, let theta is equal to 0 here. Suppose if angle is 0, what happened? A vector dot B vector equal to AB cos 0. Cos 0 is 1, so that means it is AB. That means A vector dot B vector is equal to AB if there is no such angle. That means it lies in the same direction it is. See, this is OAB, this is A, and this is O to B is B, lie in the same direction, angle is 0, obviously this answer is A dot B is equal to AB. This is property number 2. And here it is subdivision 1. Supposing if theta is equal to pi, what happened? If theta is equal to 0, cos 0 is 1, so angle, the answer is AB. Suppose A dot B is equal to AB cos pi. Cos pi is minus 1, so cos pi is minus 1. So in this case, let me draw the diagram. This is A, this is B, angle between them is like this, it is pi. That is opposite in direction. Two vectors are lie in the same direction, A dot B is equal to AB. Two vectors are in opposite direction, the answer is A dot B is equal to minus AB. Remember that. The first case, two vectors lie in the same direction, that is A dot B is equal to AB. Two vectors are in opposite direction, the theta is pi, if, obviously the answer is A dot B is equal to minus AB, and theta is equal to pi by 2. What happened? A vector dot B vector equal to AB cos 90, cos 90 obviously 0 here. Cos 90 0 means here one vector, here another vector, this is A, this is B, they are perpendicular, so that means A is perpendicular to B vector. So A perpendicular to B. This is the value for the second part. So we just first case theta is equal to 0, second case theta is equal to pi, and third is this. And third case we can take sub cases also here. So it may be A vector is equal to 0, B vector is equal to 0, A and B are perpendicular, sub cases. Remember that A, B, C, here 3 sub cases. A dot B is equal to 0 means, here remember that A vector dot B vector is equal to 0. There are 3 sub cases I have defined. One is A is 0, maybe one vector is 0. or B vector is 0 or A and B are perpendicular. Now the first case A dot B is equal to AB means vectors lie in the same direction. A dot B is equal to minus AB means vectors lie in the opposite direction but they are parallel. Here it is a parallel, here it is lie in the same direction but in opposite, and here two vectors are perpendicular. This is the case number. So here the third property is A vector dot A vector. So that means in the place of B there is A. That means what happened? Theta, it is nothing but 0. Cos 0, 1. So obviously answer is 1. So A into A, that is cos 0, nothing but A square. This we can write in vector form, that is modulus of this. So A dot A is a very important result. A vector dot A vector is modulus of A vector square. Based on that, many properties we can have. So how it is? Now fourth property, with the help of this result, A vector plus B vector dot A vector minus B vector. Remember that, A vector plus B vector dot A vector minus B vector. You know what is A plus B and A minus B? In algebra we know it is A square plus B square. Here in the same way I can apply A's modulus of A square minus modulus of B square, like this. And second subcondition A, here it is A vector plus B vector square plus A vector minus B vector square, 2 into modulus of A square plus modulus of B vector square. So this is the property, will be very helpful for doing problems. So very important property, and based on these properties it is very much helpful for doing sums. All these properties, if you remember all these properties for doing problems, without help of this you cannot do so even a single sum. Now this is the simple and easy property for your reference. And property number 5. See how these properties are very much helpful for doing problems. Lambda into A vector dot mu into B vector is equal to, in what way I can write upon this one? So lambda A vector, so it is a linear combination of A, linear combination of B. Lambda is a scalar quantity, mu also scalar quantity. By way of multiplying this, in what way? It is by way of multiplying this dot and this. That means lambda mu A vector dot B vector. In this way also we can write. Or see, lambda A mu B dot, I can write it as lambda mu A dot B. In other words, lambda mu A dot B or A dot lambda mu B. So while you are doing sums only, we can differentiate all these things. So it is very important while you are doing sums, this property is very much helpful doing problem. And property number 6. And this lambda and mu are scalars. Lambda and mu are, what is that? Scalar quantities. Okay. Now, so sixth is, so lambda A mu B, like this we take distributive law. Distributive law, we need 3 vectors and 2 operations. 3 vectors and 2 operations. What is the 3 vectors? A, B, C, and 2 operators means one is dot, other one is addition or subtraction also we can take. So let us take this one as a first subdivision, A vector dot B vector plus C vector, that is A vector dot B plus A vector dot C. Remember that distributive law. Distributive law carried out, only 3 vectors are possible and 2 operations. So A vector dot B, A vector dot C. Supposing the same thing, if I want to take for minus, I can also take B vector minus C vector. I can take A dot B minus A dot C. So in other way also I can take this one, that is third property, as A vector plus B vector dot C vector. So that means A dot C plus B dot C, remember that. So now we can write in either way, that is A dot B plus C or A plus B dot C. These two ways I can write, and here it is a subtraction. So the distributive law I can write according to the version, according to the way in which we have written like this. So this is the distributive law, and the next part of it is angle between two vectors. Angle between vectors. Angle between two vectors, we have to use the formula, you have to use the definition. What is the definition of A dot B? A vector dot B vector is equal to AB cos theta. So holding cos theta on left hand side and writing remaining value to this. So that means A vector dot B vector by AB is equal to cos theta. That means cos theta is equal to A vector dot B vector by mod A mod B. In other words, I can write cos theta is equal to A vector dot B vector by mod A mod B. Remember that. So this is the way I can define about all the 7 properties. Still few more properties are there, we will discuss.